Alright, so the stem head bearings in the bike were pretty ratty. For anyone that doesn't know, the original bearings in these bikes were just loose ball bearings. But I've got these Pro X tapered rollers to replace them with. Tapered rollers are much better than ball bearings because rollers have much more contact area, which will help to reduce any play in the stem head itself. So the first thing we're going to do is knock out the old races for the loose ball bearings. So I've got a piece of Rio bar because I don't have a pin punch long enough, and we'll just try and knock that one out. That was pretty easy. Now for the top one. That was way easier than I thought it was going to be. Alright, so there's the old races. Alright, so here's the new tapered roller bearings. Obviously there's a top and a bottom. The narrow one is for the top and the wider one is for the bottom. Which is pretty obvious because the stem itself is tapered, it's thicker at the bottom and narrower at the top. So, we'll knock the top one in first, I reckon. So obviously the taper faces in towards the stem itself. Right, we'll just sit that in there. Place a bit of wood on top of it and just try and knock it in. Probably should have picked a stronger bit of wood, but whatever. That just does not want to go. Let's find a bit of wood. Alright, that piece of wood just wasn't cutting it, so we'll try this one. I know I probably shouldn't hit the race itself, but it's a copper hammer and I'm only tapping it. So that's as far as it's going to go, but the lip of it is still just above the top of the stem itself. That's as far as it's going to go. Well, try the bottom one. You're getting me. Oh wait, there we go. Alright, so that's all the way up in there. I'm going to have to drift that in with something because it's actually inside the lip of the stem itself. Shit. And we're going to do that. Alright, so I should really use a brass drift for this, but I don't have one, so I'm just going to be really gentle. It doesn't feel like it's that tight anyway, so it should just tap in. There we go. Right, now to grease the bearings. Probably would have been a lot easier before I put it on the shaft, but I kind of jumped the gun, so I'll just have to work with it. So I'm swapping these forks left to right so I can get the mounting points for the caliper on the back. These bikes always have the calipers mounted on the front of the forks and I want to mount it on the back. And I'll cut to a video explaining my reasoning behind this. Okay, so the reason I want to move the caliper behind the forks is to improve the handling of the bike. But to explain how it will do that, I'll need to start with a few basics of steering geometry. The first thing I'll go over is the steering axis. This is the axis around which the front wheel pivots, and it can be found by drawing a line directly through the stem head down to the ground, as you can see on the picture in front of you. The next important thing is the trail. This can be determined by measuring the distance between the point where the steering axis intersects the ground and the point at which the front wheel contacts the ground. As you can see in the picture, the wheel contacts the ground behind the steering axis. The reason for this is so that the forward motion will pull the wheel into line and stabilise the bike. The more trail you have, the more stable the bike will be, but the steering will be heavier and less responsive. The smaller the trail, the quicker or more responsive the handling will be, but less stable. So now that we've established where the steering axis is and how the wheel centres itself through the forward motion of the bike, we can move on to the effects of repositioning mass around the steering axis. As you can see in the picture, the centre mass of the caliper is offset from the steering axis and pivots around it as the front wheel is turned. In front of you now is a picture of a pendulum. Imagine that the pivot for the pendulum is the steering axis and the bob at the end of the string is the caliper. For a pendulum, the force pulling the bob back to the centre line is gravity, but for the bike, it's the forward motion pulling the wheel back into line. Momentum is the force of motion that carries the bob past the centre line and out the other side. This is calculated by multiplying the velocity by the mass of an object. As the wheel is pulled back to the centre, the caliper gains momentum, and this momentum carries it past the centre and out the other side, until the force of motion exceeds the momentum and pulls it back again. This process repeats and, unless overcome by the rider, results in a speed wobble. The greater the momentum, the bigger and more powerful the speed wobble becomes. So in the example on the screen now, the offset of the caliper has been halved. This halves the distance that it travels for any given movement of the front wheel, which in turn halves the velocity and the momentum of the caliper. By moving the caliper as close to the steering axis as you can, you reduce the momentum of any involuntary front wheel movements, making them easier to overcome, which improves handling.